Okay. Good morning, everyone. Today we are going to continue on our lecture on continuous random variable. What we have started last week, listing some of the definition and the properties of continuous random variable. What we found that the PDF fx of x is known as the small letter f here is known as the PDF, which is the probability density function. Now, as actually must be always be positive. It can be larger than 1 because it is a density function. It is not a probability function. It's not a probability, but it's a density function. Again, this is a PDF value. The value of x here would be real. It's a real number. So it need not to be a discrete set of numbers. It's a real continuous number. So what we are interested in is basically a region, an area of, an interval of interest. When we want to find the probability, we are going to find an interval of interest, such as what we see in property number 4 here. So the first property that I've listed here is basically the PDF must be always larger than 0. The second property is a link between CDF and PDF, the second and third property. The capital F here, if you recall, is going to be your CDF, your cumulative distribution function. And the fifth property here, if you notice, is basically if you sum everything up together, it must be equal to 1. So today what we are going to look at it, we are going to do more examples regarding PDF, CDF, and then we'll touch about expected values and variance. As time permits, we are going to look at a few family of continuous random variable. We specifically look at uniform, exponential, and Gaussian. I'm not sure whether I have enough time to cover all three. If not, I'll cover as many as I can. And for the next lecture, we are also going to look at mixed random variable, which means it combines both continuous and discrete random variable, and we'll introduce a concept about an impulse function. That's for the next lecture. So if you have any questions, you can actually ask on the chat line. You can stop me, and or you can raise your hand, and then you unmute. And then when I call your name, you can unmute yourself and can ask me the question directly. Okay. Now, in the first question here, what I've given you with fx equal 20 between 10.5 to 10.55. Basically, if you think about it, what we have is basically 10.5, 10.55. If I draw it out here, and you got x. And the height is 20. Okay, because fx of x is on this region here. So the question is, we want to check whether it's a valid PDF. What should we do then? According to the properties we've listed out, you can already do it. So what can we do then? How do we check whether this is a valid PDF? Yes, you integrate it. Once you integrate, what should you get? 1. Now, of course, this is one way to do it. We can integrate very quickly, so we will check here. Because the whole region is just 10.5 to 10.55. 20 of dx. So this is actually 20x going from 10.5 to 10.55. So this 20 times 0.05. Okay, so this is equal to 1. So this is a valid PDF. Now this is just blind using formula. But if you look at it carefully, what does integration mean? If you look at the equation here, what does it mean? If you look at this equation here, what does it mean? 20 is your height. Dx is basically the x value. Since the x value, so this x value here, so it's 20 times the x here. So it's actually area under the curve. Yeah, thank you. So it's actually area under the curve. So the other way of looking to it, you are solving the area under the curve. So sometimes you don't need to do integration immediately. You can actually calculate the area under the curve. And that means another way of solving it is basically area is actually equal to 10.55 minus 10.5, okay, times 20. So this is also equal to 1. So this is also valid PDF. So the other way of looking to it, the area under the curve must be equal to 1. So you usually do not need to rush into doing integration. Sometimes if it looks simple enough, you can just use the standard formula to do it, and you'll notice that's what's going to happen most of the time. Now, how do you find CDF of X? Now, this is where a lot of students get confused. The idea here, maybe I don't want to use X. Now X here, because CDF of X, which is Fx of X, this X here now is a value. Okay, so maybe I use U here, Fx of U. So it's the same thing. I just call, so that what we have here, 10.5, 10.55. What we are doing here is basically we have an X value, but it depends where the X value is. If my X value is somewhere here, that means case 1. If X is less than 10.5, what will happen? The area that we are interested in is this region. So what's the area? What's the area that is covered? Any probability and the region Fx of X smaller than X? Because Fx of X, CDF of X is just negative infinity up to X. Fx of U du, which is actually probability of X less than equal to that value of X. So the answer here is 0. Case 2, my X can be between 10.5 and 10.55. Because in this case, my X can be anything here. So the region is less than X is this here. So the only region of interest, if you can think about it, is only this region only. Okay, this is the only region, the way I've sketched in red color here, because that's the only area with probability, isn't it? So you can calculate your CDF here now. In this particular case, Fx of X, we don't need to, you can use what we call integration from 10.5 to X times 20 dx, or you can find the area, which is 20 times X minus 10.5. Okay, maybe I don't need to say times here so that students don't get confused here. Maybe I just say if X is between 10.5 and 10.55, my answer is going to be, my CDF is going to be 20 times X minus 10.5, because that's the area. And of course, the final case here, which is very straightforward, which I could write somewhere here, the case 3. when x is larger than 10.55, what is my fx of x then? Okay, if it's larger than 10.55, that means my x is going to be here. So it covers the total area. So the answer is going to be, my CDF is going to be, what's my CDF then? When is when the x value is larger than 10.55? 1. Because you are covering, if my x is here, so the total region is going to be covered. So it has to be 1. And remember, CDF always goes from 0 to 1. With continuous random variable, if I sketch it out, it's going to be, let me erase this part so that we can have space to, if you have, it's going to be continuous, okay? There is no jump. If you recall, with discrete random variable, we have jumps. But with continuous random variable, we have no jumps. It goes from 0 to 1. So for our case here, if I draw the CDF of x, so it goes from 0 up to 10.5. And from 10.5, it's going to be go up linearly. It's going to go up linearly until it reach 1. Okay, it goes to 10.55 here. It must always go, remember for CDF, it must always go from 0 to 1. So straightforward enough. This is a very, very easy example. But it's straightforward to understand. If you have any question, please stop me, okay? If you don't know what I'm doing. Let me give you a second example. Fx of x is equal to negative 2x and 0 is from negative 1 x to 0, and this is 0 otherwise. So if I sketch this one out, it looks something like that. And when x is negative 1, this is negative 2. Oh, sorry, this is 2. What do you mean by negative 2 here? This is 2. Because negative 1 times negative 2, negative 1 times negative 2 is going to be 2. Remember that one thing that you have to remember, because this is a CDF, all the values here are positive. All the values must be larger than equal to 0. It cannot have area which is below the x equals 0 line. Okay. So the first question that I asked, is this a valid PDF? So of course, it's very straightforward. Now, do you need to use what we call integration to solve this question? You can use it, but you do not necessarily need to use it, isn't it? Because it's just area under the graph. So it's a valid PDF because if you look at the area under curve, it's just only equal to half times 1 times 2, which is equally 1. The total area here is equal to 1. So you don't really need to, sometimes you don't need to rush into doing it. It's up to you what to do. Now, I want to find the CDF now. Okay, I want to find the CDF now. So of course, the case you have again, I could depend. My X value can be here, or it can be somewhere in the middle with the same formula all the time. You keep on moving my line. If I keep on having a line here, I could have three different cases. Case one, you know that when you because it's the CDF is to the area to the left of the line there. So for the case one, where it's usually the first case, the last case we already know, because for case one, x is smaller than -1, then fx of x is equal to 0. And we also know case 3 already. When x is larger than 0, fx of x should be equal to 1. So to the left, to everything to the left is going to be to the left of the smallest value of the smaller value of interest is always going to be 0, and the one to the right, to the CDF to the right of the largest value of interest is always going to be 1. It's always going from 0 to 1. So what we are interested in is only when x is in between. So in this particular case, for case 2, x between -1 and 0. So you have to be, if I draw this one here, so this is my x value here, because x can be any region between -1 and 0, and we are looking at this thing. Okay, of course there are, you can easily find it because you can just do the total area minus the, but there's there is an, maybe what I should do, I do something and then you tell me whether it's the right answer or wrong answer, okay? And then just check with me to see whether I've done it correctly and tell me why if I have done it wrong. If I've done it correctly, let us prove that. If you think you have done it, I have done it correctly, let us try to prove it using formula. Okay, and then you see whether we have actually done it correctly or not. So what's the simplest way to do this? If you don't want to use integration, the simplest way is what? Okay, how do you do it? How to find the area under the curve? Because you can use the trapezium rule. You can what else? What do you do? Okay, so it's the total area of the triangle, which is 1 minus a small triangle, isn't it? So what should you do? You got 1 minus what? Minus what? Half times what? Some of you say negative x, some of you say x. Okay, I just follow what you say. Majority say x times what? If this is x, what is this one? The equation is what? -2. -2. If this x is going to be what? Yeah, play x is, according to equation, is going to be what? Some of you say -2x, some of you say 2. What is the one? According to this equation, if I plug x inside here, what do we get? You got negative 2x, you got 2x, you got let more people to, I just have to follow. Okay, majority say negative 2x, so I just follow negative 2x here. Okay, so what we get here is 1 plus x squared. Is this correct or not correct? If it's not correct, why? If it's correct, if you think it's correct, we'll move on and I can tell you. Can you tell me whether this is correct or not correct? Yeah, Kevin say no, but it's still a y. Darren say no, it's still a y. Darren says more than 1. Because x squared is always positive value, 1 plus anything is always larger than 1. So guarantee this is wrong. Where have our error comes in? Because it's more than 1, no? Because this is larger than 1, which is not possible. But where's the error? That's not the error. The error is actually at the x part. Remember, x is a negative answer. Can your length be negative? Because you are using the formula to do it, can x be a negative? Because x is between negative 1 and 0. So that means x can be a negative answer. So what you should have done? You should have put here. It's not 2x. 2x is a positive answer. Because x is negative, applying negative, if x is negative, because x, you look at it, is defined as a negative number. And then what happened here is, I put negative here, this number is positive. So negative 2x is a positive number. I have no problem. So yes, the problem comes in with this x value, which is a negative number. So if you use the area formula, you must remember everything has to be positive, isn't it? So what we need to do, the one way to see is actually 0 minus x. The length is actually 0 minus x. What's the length of this? It's 2 minus 1, isn't it? The length is 2 minus 1. What's the length of this? It's 0 minus minus 1. What's the length of this? It's x plus 1, isn't it? What's the length of this? It's 0 minus x. So it's negative x. So you just have to be careful when you use the formula here. Now, sometimes very quickly, you also need to be able to observe that your answer is wrong. It's good that you can see that your answer is wrong. That's what you need. You must have this intuition that your answer is wrong. So what I do now is 1 minus half negative x times negative 2x. Because the length here must be negative. It's 0 minus x. Now, this becomes 1 minus x squared. Let us see whether we have done it correctly. Let us double check. So the other formula, the other way we can do it is fx of x is equal from negative 1 to x, because we are working in the region between negative 1 and 0. And our formula here is negative to u du. Okay, because I just want to make sure that I just have a change of variable so that we don't confuse. Sometimes which one you prefer to use, u or x prime? Usually, which one you use? I've used both before. Do you prefer to use x prime or you prefer to use u? So let's say this u, this fx of u. Okay, I use u here. I just have a change in variable so that we don't confuse the x value with the variable. Okay, this x value is a fixed value when it comes to CDF. So what you get here is just negative u square. Go from -1 to x. Okay, which is going to be negative x square. Okay, minus -1, which is actually 1 minus x squared. Now, if you have done it correctly, you can check it very easily. How do I check it that I have done it correctly? You can check it when fx, because our region is up to 0 here. If when I put fx of 0, it should be equal to 1, isn't it? The most extreme right-hand point is equal to 1. Is it true or not? You plug in 0 inside, it's going to be equal to 1, so it's true. So it's always true. You always can check at the margin. When fx at, because our region is from, when it's -1, if I plug -1 inside, this should be 0. Because remember, I told you it's continuous. It must go up to 1, and it must actually, what we call, goes from 0 to 1. It must go, so at 0, it has to be 0. Sorry, at this at -1, isn't it? When it's -1, it has to be 0. When it's at 0, it has to be 1. It has to go from 0. It has to go flow from one point to the other point. So if you look at the boundary, you can check whether your answer is correct or not. Can you know how to draw this? 1 minus x squared. Do you know how to do drawing? Because sometimes I ask that in the test. Okay, Yap Kenwon, it's okay. I'm talking about the rest of you. Make sure you know how to draw it, because what happens is, x squared, you know how x squared looks like? Because I'm drawing from -1 to 0, okay? X squared looks like what? It looks like this. Okay. Agree? This x squared. Okay. Do you know how to do you get this is x squared because 0 is here, -1 here. This x squared. Agree or not? Negative x squared means what? How does negative x squared means what? Now I want to draw negative x squared. What will happen? It flips over. Is 0 because I'm interested from. So what happens is it goes down now. It's the same thing, but it goes down. So this is -1 here. No problem. It goes like this. This is negative x squared. And then so now I 1 minus x squared, which means everything have to plus 1. When it's plus 1, what's going on? When I plus 1, what do I get? It goes up by 1. So suddenly now, if I redraw my thing, everything is shifted up by 1. So you want to shift up by 1 now. If I shift up by 1, what does it look like? Maybe I draw it here. So everything looks the same. It's something like that, isn't it? But previously it's on 0, now it becomes 1. So this 1 minus x squared drawing. But we are only interested from the -1 to 0 term. That's why I'm only drawing this part. That's why I only draw. That's why I know it's a concave up curve. Okay, that's why I draw this curve here. I know it's a concave up curve. Okay. So, but larger than 0, fx of x is equal to 1. So that's what it is. Any problem? So you should be able to, right? Because I've asked this sort of question before in the test, and students in generally do not know how to draw. Okay, as an engineer, you should learn how to do graphing. Okay. No questions so far? Let us continue. This is just another simple question, just to test your understanding. This is another example. This is just to test your understanding here. I want to find A, find C. How would you do? How would you have done it? This is a CDF. Remember, this is a CDF. So be careful about it. Look at the question carefully. This is CDF. It's not a PDF. So you cannot just everything equal to 1. Okay, this is CDF. It's not a PDF. So be careful. So how would you have done it? What do you think your C is? There are 2 ways to do it. There's one shortcut, there's one long. Okay, differentiate is a long way of solving it. And then you integrate everything into 1, no problem, but there's a shortcut. This is a very easy question, but sometimes we think too complicated. Why 1? Why FV at 1 for our? Why you want to find FV at 1? Why do you want to find CDF at 1? This is CDF. Remember the property of CDF we said before. It must flow continuously from 0 to 1 and with no discrete jump. With discrete cases, there will be a jump in your CDF, but here it always flow from 0 to 1. So by looking at the boundary, we can often use it to check. Of course, we already know it already. Actually, you are there already, Jeff Cameron, but you are thinking too complicated. You have to, like, if you look at this case, there are 2 points we can do checking, which is at the edge here. We can check it to see. We know that fx at -1 should be equal to 0, fx at 0 should be equal to 1 because it has to, because we know what happened on the third case, we know what happened on the first case. Yes, so all we need to do is to check at the edge here. At -5 here, guarantee is 0, so no problem. But at 7 here, it should be equal to 1. Okay, f7 should be equal to fv at 7 should be equal to 1. So c is equal to 1 over 144. You have to be careful about what you're looking at, because I've caught students before in the test because they don't look at they don't look at the what we call whether asking for PDF or CDF. Now, this is one case. Now, another example, this is the example we are looking at normally. Fx of x equal to Cx, x between 0 and 2, 0 otherwise. That's the one that, because it's a PDF here, so this one, you know that if you integrate everything up here, it should be equal to 1. Okay, so make sure that you, are we looking, so whatever you're doing, make sure you know whether you're looking at CDF or are you looking at PDF. These two questions I asked before. So you have to be careful when you are solving the problem. Any question here? I don't think I need to solve the second example here. The next, clear cut enough. Like in this case, it's very straightforward because cx squared over 2 from 0 to 2 is equal to 1. So c times 4 is equal to 4 divided by 2, isn't it? So c is equal to half. Okay, or if you know what to do, because cx is just only look like that. This is 2. Okay, the other way of solving it, because this is c, because if I draw it, so it's area under the curve, so it's half times 2 times c must be equal to half times what we call, have I done it correct? Is it c equal to half x squared over 2? Okay, make sure I've done it correctly here. 4 over 2 and then 0. Okay, or cx, so it is 2c, sorry, times 2c here. So cancel up, so c is equal to half. So it's the same answer here. Okay, because when x equal to 2, fx of x is 2c. Any question? Now, let me move on. This is a little bit harder example. Just a little bit harder. Fx of x is equal to 3 over 4, 1 minus x squared, where x is between 1. Okay, it's a magnitude of x is actually less than 1, which means x is between 1 and -1. Okay, again, the validity of this should be easily proven. We can just easily prove that whether it's valid or not. Is it valid? This one we know already how to do it, but very quickly we look at whether it's valid or not. Between -1 to 1, 1 minus x squared. Now this one is harder to do because it's a 1 minus x squared curve. Okay, it's 1 minus x squared curve, which is going to be harder. Okay, so that's why because it's a quadratic curve, so to find the area under curve is going to be a lot harder. So what we do now here is 3/4 times x minus x cubed over 3 from -1 to 1. Now, if you know what to do, you know this is an even function. So we can just, the area on one side multiply by 2 because this function is an even function. If you know what to do, you don't need to, you can go 2 times 3/4 x minus x cubed over 3 from 0 to 1. It's the same answer. But let us actually 1 minus 1/3, okay, times 2. No problem here. Because when I put -1 inside, it gives me a negative answer. So minus minus become positive. So this is 3/4 times 2 times 4/3 basically at the end. So the answer is 1. No problem here. Now, this is not what we're asking. Okay. What we are asking here is I want to determine the probability that 8x squared minus 6x plus 1 is larger than 0. I want to find probability of 8x squared minus 6x plus 1 is larger than 0. That's what I'm asking for. Given that x, the distribution is as given. How are we going to solve it? In this question, we need to find out what are the range, you remember when we find probability, we want to find the interval. We want to find the probability of the interval. So we need to look at the interval which fulfill this condition. Okay, so let me draw this curve. Never mind, we will draw it later on so that we won't make a mistake there. So can you tell me what are the range that fulfill this condition? We can actually write it as x squared minus 3/4x plus 1/8 must be larger than 0. Can I write this? I divide everything by 8. And there are what are the possible intervals that fulfill this? Half and 1/4. So you got probability of x minus half, x minus 1/4 must be larger than 0. So what are the range of x that fulfill this condition? This goes back to what you learned in secondary school. How can it be larger than 0? What value of x would it be larger than 0? I thought we might have discussed this before. So you got 1/4, you got half here. If you look at the case here, half, if I plug in, if I just look at x minus half alone, I just look at x minus half here alone. If any value larger than half is going to be positive, any value smaller than half is negative. Remember that? Now, then I look at x minus 1/4. Anything larger than 1/4 is positive. Anything smaller than 1/4 is negative. Okay, let's say 0 is smaller than 1/4, so 0 minus 1/4 is negative 1/4. So that's why it's negative. So what are the regions which actually give me, if you multiply both of them, it will give me positive answer. What are the regions then? x larger than half and x smaller than 1/4. So you have two regions here, x larger than half, okay? Or, that's why I union it, x less than 1/4. So I have two intervals now. I have an interval on this side, I have another interval on the left-hand side. And these two intervals are mutually exclusive. There's no overlapping. So I could write it as px larger than half. Because they are mutually exclusive, what can we do? Because they are mutually exclusive, what can we do? The two events are, if it's larger than half, it cannot be smaller than 1/4. So what can we do then? Yes, we add them up together. So we get px smaller than 1/4. So we just need to have two regions. So now we can do our integration. So for x larger than half, what are the limits that we are going to use? For probability of x larger than half, what are the limits that we want to use? It goes from where to where? Half to where? Should we put to infinity? Because our range of value here, if you look at it, 1 minus x squared looks something like that. Your range is actually looks something like that. Okay? This is how it looks like. It's from -1, so from -1 to 1. This side is 3/4. It's fx of x here. So x larger than half, half is somewhere here. So it goes up to 1. You don't go to infinity because of what? Because the range of, if you draw it out, you notice that my PDF is only up to 1 only. So I just do it up to 1. 3/4, 1 minus x squared dx plus, what about the other side? What are the limits? It's from -1 to 1/4. Okay. So this becomes 3/4. Okay, it's basically x minus x cubed over 3 from half to 1 minus x minus x cubed over 3 from -1 to 1/4. I'm not going to calculate the whole thing out here. You can actually calculate this out. But what I want to show you is that this kind of question, I think it happens once only in the final. Unfortunately, many students didn't do it, even though I've taught this in class. But when it comes to the final, they've forgotten what to do. Okay, so you must get it correct. The integration values, you have to put it correctly. If you have put it correctly, then you get full mark. Now, just for some what we call context here. For the exam now, I'm less focused on the right answer at the end, okay? But for the quiz, the right answer will have some marks. Any questions so far? Okay, now I would now like to introduce you the concept of expected value. Now, for discrete case, we already know how to do it. It is basically very straightforward summation of x times Vx of x. For continuous random variable, then it's just x, the PDF of x, yeah, and it has the same meaning. Okay, it has the same meaning. So, but some of them you don't need to do much already. Let's say, for example, here we go back to our example. 10.5, 10.55. This is 20. Okay, fx of x. Now, in this case, do I need to actually calculate the expected value of x? Do we actually need to use the formula? Do you know what the answer is without calculating? What's the answer here? Without actually even using the formula, do you know what the answer is? It's right at the middle, isn't it? The expected value should be right at the middle here. So you should know it's 10.55 minus 10 plus 10.5 divided by 2. The same thing. So what the answer is? 10 point, I think it's 525, is it? So if you can see that it's going to be 10.5, 10.55 x is 20, x, which is 20 x squared divided by 2, which is 10x squared only, from 10.5 to 10.55, which is actually equal to 10 times 10.55 square minus 10.5 square. You have a calculator. Let us calculate it. So we got 10.525. Now, you remember when it is symmetrical, we just take the middle point for expected value. So there are some of them which is pretty easy, like even the one that we have done just now. If we go back to the previous case, all this case is easy. Like in this case, what's the expected value? For this particular example here, what do you think is the expected value? Without even doing it, do you know the answer? Yes, because right at the middle, because it's symmetrical left and right at the middle is a 0 point. So the answer is 0. So we do not need to solve it. Okay, so sometimes don't waste your time solving it. I think in the final exam, I've seen too many students wasting the time solving it. Now, let's move on to another example, which is slightly this case, unfortunately, you need to have more what you call time here. 0, -1. Okay, and this is the one that we have is negative 2x. Okay, very quickly here, expected value of x is just only from negative 1 to 0, x times negative 2x dx, which is actually equal to negative 1 to 0, negative 2x squared dx. Now, before solving it, should my answer be closer to negative 1 or 0? Should my answer be closer to negative 1 or 0, my expected value, even before solving it? Negative 1, because it's the density is higher on the negative 1 side. So let us check whether we are correct or not. So what you get here is negative 2x cubed over 3 from negative 1 to 0. So that means what we get here is 0. It's actually at the end is 2 over 3. So the answer is 2 over 3, which is closer to, sorry, have I made a mistake? Okay, 0 minus, yeah, is I make a mistake here. Because it's 0 minus, yeah, negative 2 over 3, sorry. I make a mistake in my calculation. Because it's 0, it's actually 0 minus 2 over 3, so it's minus 2 over 3. So minus 2 over 3 is closer to negative 1. So again, often we can kind of guess where the answer is, okay? So you know whether you have done it correctly or not. Any questions so far? So none, isn't it? Very straightforward. Variance, if you want to find variance, you just need to find expect. So you want how to find variance of x. So it's the same idea again, because variance of x is just only ex squared minus ex, the whole thing square. The rest is just pure maths, nothing else. Okay, it's just pure maths, nothing else. I do not need to show you much example here. Let me see how many of you now. Is it worthwhile doing breakout room? 16 participants. Okay. Now let's see. We have not many of you here today. Now I give you this question and I try to solve it. Now this is a little bit more work that needs to be done. Example here. This is an example I want you to try to solve. Fx of x, I give you CDF of x is equal to 0, x over 2, 1. X smaller than 0, x between 0 and 2, x larger than 2. What I want you to find is variance of x. So to find variance of x, of course, you have to go expected value of x. Since I've given you CDF, so you should be able to what we call find the PDF first and then do the work. You have to find the PDF. Okay, but this is a very simple question. I just want to see how you are doing it. Okay, no problem. So I put you guys in breakout room. Since there are 16 of you, I break out into 4 rooms. Each room with 4 students. Okay. So I'll stop recording for the moment. Okay. Okay. Let us continue with our lecture, and we figure out. I think only one of the group figure out how to solve this question. And because what we are given here is a CDF, so the first thing we have to find is a PDF. And the PDF is just only fx of x. It's just you just need to differentiate. You just need to differentiate fx of CDF of x, which give us only half when x between 0 and 2 and 0 otherwise. So what you're looking at is basically you got 0 to 2 half. So you got fx of x and x. And to find ex here is straightforward, the expected value of x, because this is just 1, because just right at the middle. So the only, to find variance of x, we need to have ex square minus ex, the whole thing square. So what we now need to find what is ex square. And even though I didn't show it, the idea is similar to what we have done in discrete random variable. That's why sometimes you have to be able to transfer what you've learned from one section of a lecture to the other section. Because PDF, if you look carefully, what we have done in discrete is just similar, just that we change the summation into integration. That's what we call transference of learning. Learning is not just about learning for this subject, only learning for this topic. We don't need to bring forward to any place else. But you have to bring forward what you know from before and what we call, and actually transfer this learning to the other part. Similarly, what you learn here, can you transfer the same concepts to another course later on, and later on to life? Okay. So what happened here? All we need to do is just x squared fx of x dx. It's just like what we have done before. This is just a losses. Okay. What we have done is losses. If we put x cubed here, we put x cubed in front. We put gx, it becomes gx. And our range is from 0 to 2. So this is actually 0 to 2 half x squared dx. So this is going to be x cubed over 6, which is from 0 to 2. So this is going to be equal to 4 over 3. So right now, variance of x is just 4 over 3 minus 1 square, which gives us 1 over 3. Okay. Okay, let us continue for just a short little more longer. No problem. I think one group got it. The other group got it or not? I think group number 4 or 3, they almost got it. Did you manage it? Yeah, I think you finally got it. Because I think there's a dispute between your own group how to solve the problem. Okay. So finally, the other two group also got it. So that's great. So it's as simple. I think most of you start at ex squared. Breakout room 1. Room 1, are you okay? Any question? Belinda, and who else in that group already? I forgot. Aaron and Wong Se.
Yeah.
Okay, you know what I'm doing here. Sometimes, if you know that it's symmetrical, you don't need to calculate the maths. It's a simplified method. I can write it down very quickly. The answer is 1. Okay, because it's right at the middle for ex. Ex squared, unfortunately, you have to find it. Okay, let me continue for a little bit longer. Now, the previous example just now is actually something what we call a uniform random variable. Actually, for me, I did not even need to use this because this is given in the table. Uniform random variable, basically the idea is you got A and B here. And if the total area must be 1, this must be 1 over B minus A, which means my PDF for a uniform random variable is just 1 over B minus A when X is between A and B. So it's a constant. Uniform, that means the density is constant within the range. Normally, we use this if for things we do not know. This sort of PDF, we use it when we have no idea what the distribution is. We just assume that it's uniform. most of the time. But in real world, basically almost uniform is seldom actually applicable for any application in general. But to make life easy, sometimes to do calculation, worst case condition, we use uniform random variable. But usually it gives us the I think the worst performance. But anyway, so the CDF of X is very simple because I take X somewhere here, and it's going to be equal to 0 when X is less than A, and it's going to be X minus A divided by B minus A when X is between A and B, as we said before, and 1 when X is larger than B, as what we have discussed before. And the expected value of X, we already know it's just right at the middle. We don't need even to solve it because it's symmetrical. X plus B divided by 2. And what's the variance of X? This is the interesting part. Because this one, we have to find EX squared. So this formula is given to you. So EX squared is equal to integration of X squared of B minus A, 1 over B minus A from A to B dx. Okay, this A to B. So that gives us 1 over B minus A X cubed divided by 3 from A to B, which gives us B cubed minus A cubed divided by B minus A. If you do long division, this becomes B squared plus AB plus A squared. If you do long division, okay? You know how to do long division. Do you remember how to do it? Okay, what I'm saying is that you just need to do B cubed minus A cubed, B minus A. If I put B squared here, I got B cubed minus A cubed. A square. AB square. I put plus AB. I got this is going to be AB square here. So I put plus AB. I got AB square minus A square B. So I got A square B here. Let me bring my other things here. Let me erase this one here first. I want to complete this as soon as possible. Okay. So all you need to do is a long division here. So we got B square. Where's my eraser here? So I got B cubed minus AB square. I got B cubed minus AB square. So give me AB square. Okay. This give me AB square, which give me all I need to do now is I need to plus AB square again. No, plus AB, so I got AB square here. Okay, and by doing that, I will get minus A square B. Okay, so I got A square B up here, and I got minus A cube here. Because the minus A cube, I bring it down. So this means that I need to add another A square here, which gives me A square B minus A cube. So this is what we have here. Okay, that's what we get here. So when I calculate my variance of X, I got B square plus AB plus A square. I leave out, I've forgotten the 3 here, isn't it? Yeah, I got divided by 3. I got divided by 3 here. So divide by 3. So I got divided by 3 minus 1 minus A plus B square divided by 4. So this gives us 4B square plus 4AB plus A square minus 3A square minus 6ab minus 3b squared divided by 12. And what we are left with is actually b squared minus 2ab plus a squared divided by 12, which turns out to be b minus a squared divided by 12. So this is a variance here. Okay, so basically when it's uniform, you do not need to solve any of this problem anymore. You just use it. Okay, you just use all these things to do your calculation, nothing else. And this is what is given in the final exam. Okay, but right now it's open book. It doesn't really mean much. You can just use the final formula. Okay, this is it for today's lecture because we are running late. We start quite late because we are waiting for students to come in. I have, let me stop the recording now.